Okay, 34. So we have this island, we have a marina, we have a boathouse, and they give us an angle, and they give us 4.5 miles. It says determine and state to the nearest tenth of a mile the distance from the boathouse to the island. So I'm trying to find this guy here. So it's like we're using trig, we got a right triangle. I'm highlighting out. That's my hypotenuse because it's across from the right angle. I have adjacent and I have opposite. So when I'm doing trig, I'm thinking so, ka, toa. So I'm trying to find h, but I know a. I'm using cosine here. So cosine of 54 is equal to the adjacent over the hypotenuse, which I don't know. I'm going to put that into NSolve. I'm going to round to the nearest tenth. X is 7.7. All right. Now determine and state to the nearest tenth of a mile the distance from the island to the marina. So now they're looking for the island in the marina. Well, I'm going to stick with this guy. I'm not going to use what I found, because if I found it wrong, then it's going to make it worse. So now I'm going to use tangent. The tangent of 54 is equal to the opposite over the adjacent. Put it into NSolve again. Y is 6.2. That's the easiest 4 points you can earn in your life on this exam. This guy says a storage tank is in the shape of a cylinder. Automatically, volume is pi r squared times h with a hemisphere. So I have half of a sphere. That's automatic from my formula sheets. The highest point inside the storage tank is 13 meters above the floor of the storage tank, and the diameter is 8 meters. So if the diameter is 8 meters, automatically the radius is 4 meters. So I want a radius of 4 meters here. Determine and state to the nearest cubic meter the total volume inside the storage tank. So if this guy is 4, this guy is also 4. All right. Now, if this whole thing is 13, this is also 4. So if the whole thing is 13, I need to find what the height of the cylinder is. That's the total. Take away this top piece, which is going to leave me with 9. So here's what I'm looking at. Volume is pi times my radius squared times my height of my cylinder plus 1/2, 4/3 pi times my radius cubed. I'm substituting that right into my calculator, okay, just as it is. I'm not finding anything separate. I'm finding it all at once, and then I'm going to round it. So I get 586.4306. So my volume to the nearest cubic meter is a whole number. That would be 586 cubic meters. Now, if you choose not to put that, that's fine. But if you put meters or meters squared, it's completely wrong. Okay? Again, I think that's a very doable 4-point question. All right, this guy here, triangle ABC and ADE are graphed on the set of axes below. Determine and state the transformation that maps ABC onto ADE. Now, I'm just going to check A to B to C. That's clockwise. And A to D to E, that's also clockwise. All right, so it only looks like a dilation occurred. So when I'm talking about a dilation, you need to tell me the center of dilation, and you need to tell me the scale factor. Now, the center is A. A didn't move. Okay, A mapped onto itself. It didn't move. That's the center. Now, the scale factor. You can try to play around with your compass. I can take AC. That's 1. That's 2. Looks like 3. I can go here. AB 1, 2, 3. Okay, I can also do that. I can measure BC. 1. It's 1, 2. You know, that one kind of looks a little skewed. So if you're not sure, you want to be exact about your scale factor. Scale factor is always the new length over the old length. And I know that none of these are horizontal or vertical, but you could actually do Pythagorean theorem. So I'll do AE and AC. That's new and old. Okay, because ABC is mapping onto, so that's the pre-image, that's the image. So if I do AE, I'm just going to make a right triangle, and I'm going to count. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is 1, 2, 3, 4, 5, 6. So that would be the square root of 12 squared and 6 squared to get to AE. So 12 squared and 6 squared is what we're dealing with there, which would be the square root of 180. And if I do A to C, 1, 2, 3, 4, 1, 2, that's 4 squared, and that's 2 squared, that's the square root of 20. If I take the square root of 180 and put it over the square root of 20, and I put that in my calculator, the square root of 180 divided by the square root of 20, that does give me a scale factor of 3, so I verified it. My scale factor is 3. Now this part, explain why this transformation makes them similar. Well, when a dilation occurs, that means your corresponding angles are congruent. And if the corresponding angles are congruent, you know, what you were talking about is angle ACB would be congruent to angle AED. And I know that angle A is congruent to itself by reflexive property. So by angle, triangle ADE would be similar to triangle ABC. You could also find the side lengths, and you could show side similarity. You could also show side similarity. You know, that's what dilations do. Dilations produce similar figures because the sides are all in proportion and the corresponding angles are congruent. I'm not really sure what they're exactly going for there, but you have a couple of ways to get some credit there.